Good day, students. This video we are now going to start with our mensuration problems. Right, this drawing is under my tutor. If you want to go and print it out, maybe it will be better. Right, so let's see what's going on in this drawing. First place, we've got a rectangle area. The horizontal measurement is 40,000 and the vertical measurement is 16,500. In there we have got this area, which consists of a square, although it looks very rectangular, and a half circle. Again, it doesn't look like a half circle, but if you take that 1250 millimeter as the radius and you times it by 2, it gives you 2,500, which is exactly this. So the drawing might be a bit confusing, but work with the measurements given. Right, so let us start. Now this is typical questions that you will get in the test and the exams for mensuration. So here I've made a list of the questions. Okay, let us now see what is question 1. Question 1 says we want to determine the length of the 1,800 millimeter high palisade fence around the site. Okay, and now we're also going to start working with word pictures. And the part of this question that's in the inverted commas, that is the word picture for this question's answer. So what I will do is I will write my work picture. It's question 1 of example 1. I will write my word picture in my description column. 1,800 millimeter high palisade fence, and because we're working with length, we know that we're going to work with meter. And meter means we only have one dimension and the equal sign. One dimension and an equal sign. Okay, let's go back to our drawing. So around the site means that length around. Right, and in the previous video we have seen that for a rectangle we'll have 2 horizontal sides and 2 vertical sides, and that's exactly what we've done here. 2 by 40.00 equals 80.00 and 2 by 16.50 equals 33.00. If I now want the total area, I will add these together, equal 113.00, and that's my final dimension. Okay, and I will finish off. And as you can see, everything that's between my lines belongs together. Right, let's go to question 2. Question 2 is the length of the face brick on edge around the paved area. Again, the face brick on edge is what is in the inverted commas. Right, so we're going to write for question 2, face brick on earth, face brick on edge, that we're going to measure. Again, we want the length, so we're working in meters. Right, let's go around here. So the face brick on edge is going to go right around the square. Right, meaning we have a 2,500, and just to check, because that dimension is not given on the plan, we need to check that, and that's where we get to references and side calculations. So we're going to quickly make a small side calculation of 2 times 1250, and that will equal 2,500. So we have, in other words, checked that this is a square. And if we want the length around that, as we saw in the previous video, 4 times 2.50 will equal 10.00. Because our square has got 4 sides, that's the same. Right, let's go and look at question 3. Question 3 is the length of the 150 by 50 millimeter precast concrete edge around the water feature or the half circle. Right, let's go here. That means it's the water feature that's going to go around there. Remember, this was already a paved or a brick on edge paving. So the edge that's left over is just around there, not there as well. Right, so we will write our word picture as 150 by 50 millimeter precast concrete edge. Again, it's in meters, right? The formula for the length around the circle is 2 pi r, but remember I'm working with a half circle. That's why I'm only going to use or need half of that. So the half, the 2 and the pi are all going to go into the times column, and my radius is 1.25, and I can say equal and do that on my calculator. Right, so the R is your measurement, so that is still one measurement because we're working with length. Okay, I'm going to stop this video here now, and I will continue the area and the volume in the next video.